Hey guys, I'm going to make a basic video here showing you a quick overview of the source that I shared on LiteCode. So basically, you have two projects. You have your client side, which is your main application, and you have your server, which handles the remote secure code that you want to protect. So in your main project, you'll have a connection. You'll initialize a new client, you'll initialize the client, and then execute the code um, from the client that you want to access from the server. So if we go into client, this is just a little method that I set up to create a static shared class. So when you initialize it, it creates a private instance of the shared class interface, and this is LiteCode's way of accessing the server in order to get that shared class file, which is stored here on your server, where you see there's a 15-second timeout on this secret function. So that's what initializes it, and then once you initialize it, you can call any method from that interface. And in my instance, that was just this one method, but you can have as many methods as you want to do all sorts of things. The string is just a basic example, and I would suggest encrypting this with another method just in case, although everything is encrypted anyway through Secure Socket Protocol 3. Yeah, it also uses anonymous sockets, so I'm pretty sure it's fairly secure. You'd have to ask Dragon Hunter about that. But basically, that's the main class. Your client properties is going to tell you here your host IP, where your server's hosted, the port, connection timeout, username and password. I also suggest not keeping these in plain text like this. Use a remote variable, also encrypted, after an initial authentication like NetSeal or some other. Network key doesn't really matter. It's just random bytes. You can change that. I wouldn't mess with any of this. This is just the handshake, step size, and cipher rounds. 100 is probably good. Your private key files, don't put them in the resources of your client. Also exchange those the same way you do your username and password through some other encrypted means so that no one can access them and spoof a connection. Public key you can keep in resources or not, it really doesn't matter. It's a public key so people can view that, no problem. Then in your server, you also have the same interface where you will define whatever function is in the interface in your actual shared class. It doesn't have to be called shared builder or whatever, it can be called whatever. See, I forgot to change the name. Anyways, for my main project, inside your server, this is where you define the actual username and password. Using a global static username password is fine. You can create a list if you want, like program.users. You can add users to this, but a global static password is just fine. Also in here is your server properties. I just put it in here because instead of a new file, since it's essentially the same thing. Listen IP is nothing since the server isn't actually what is listening, but it's not trying to connect to anything. Network key must be the same, and you can include IPv6 support if you want, but I don't really think that's necessary. And let's say, for instance, our program gets cracked, right? Someone spoofed the connection. Well, what you can do is go ahead and change your connection, or say you change your keys. So let's pretend this is a new key. And if I attempt to run the program now, it should take about 15 seconds to fail. If you look here, I believe. If they spoof the connection to the server, you can just change your private keys. See, it failed. So that is one pretty good advantage to this system. Now, you shouldn't be using this as a standalone protection. You should use some other authentication system behind it, or in front of it rather, in order to authenticate the user and then securely send over these keys for authentication. Like the encrypt decrypt methods provided in NetSeal is what I used in my projects, and I've had no problems with that. No one has cracked my programs using that method. So, all in all, LiteCode is extremely helpful. Best advice I can give to you to secure your programs is to make something unique, combine it with other things, but as long as it's unique, people have a hard time cracking and reversing your stuff. I seem to have messed up something here. I'm not exactly sure what I messed up. Let's see. I don't think I messed up anything. There, I fixed it. I think, yeah, the server wasn't set to start, so that would obviously fail. So there's your data. And just to prove that I was correct before, if I were to change one of these keys, actually change it, you'll see that it should fail. If we give it about 15 seconds. It did load, but see, there was no message box system.exception in secure socket protocol, meaning that the authentication did not validate, and therefore you can fix cracked releases of your program, unless they, of course, create a local server, but it's probably unlikely. So there you go. Hopefully this is helpful. Enjoy.